Let's go through Liquid 727 minimal window subsequences. So it gives us a string S1, S2, and return the minimal contiguous substring part of S1 so that S2 is a subsequence of this part. If there is no window in S1 that covers all the characters in S2, return an empty string. And if there are multiple such minimal length window, return the one with the leftmost start index. Let's look at an example. S1 equals this kind of string, and S2 equals BD. So we'll find the shortest window in S1, which covers S2, is BCD, which is a super sequence of S2. So we return BCD in the S2, right? So that example 2, S2 is U. There is no U in S1, so return empty string. And S1 has 2 multiplied by 10 to the power 10 fourth range, and S2 is small equal to 100. So for this kind of question, right? What we're thinking about is the string matching. String matching, the most common thinking is that we can use the dynamical programming, right? So, but for this question, what will our dynamic programming value store, right? We can store, for example, this is length and this is m, right? We have int two-dimensional array dp equals n multiplied by n integer array, right? So what dpij represent? So we can store if the index I in S1 match to index J in S2, what is the rightmost starting index to this DP, right? So we can look at the example. For example, this is D, right? This is D. So in S1, this is 0, 1, 2, 3, index 3. In this one is index 1. So we'll see the DP 3, 1, right? What is the leftmost? Is this B, right? In S1. So that is 1. You are equals to 1. So so that if we can find any dpx m, right? That means sorry, m minus 1, right? That means we already matched the last character in S2. And x is the index in S1. So the x minus this one plus 1 will be local candidate of our result of the length, right? So because this is the leftmost matching index, and because we already matched the last character in S2, right? So if for this x, we have dpx m minus 1, and this will be for example we have e somewhere here, right? So this will be index 4. And this is the rightmost, that is 1, right? So 4 minus 1 plus 1 will be length 4, right? Will be one of our candidates. So let's write code. We're going to. So what is also what is the transition function, right? So actually, there is 2 kind of scenario. If the character, for example, S1I equals S2J, right? So we know this kind of dpij or coming from dpi minus 1, j minus 1, right? If that equal, then dpij is coming from dpi minus 1, j, right? So that will be the transition function. And also we need to consider the special case about the SI0, right? We just need to compare the first character. So let's write code for this. We're going to have int n equal s1 dot length and s2 equals, let's have m equals s2 dot length. So we're going to have int dp equals new int n multiplied by n, right? So for array d in dp, we are going to have arrays fill the we set -1 means there is no matching, and dpij is that we matched index I in S1 and the index J in S2. What is we store the value? What's the rightmost index in S1, right? So this will be the DP value, right? So let's do for the first character first, the first character matching. So for int I equals 0, I smaller than n, I plus plus, we're going to have if s1 dot char at I equals s2 dot char at 0, then we're going to dp I 0 equals I. Else, if doesn't equal, and we're going to have dpi equals I0 equals dpi -1 0, right? So we're going to have dpi 0 equals dpi -1 0, right? Of course, we don't want this one go to have index to be negative. So else if I greater than 0, right? Um, then what we do is that for the general case for int j equals 1, j smaller than m j plus plus, and for int I equals 0, I smaller than n I plus plus, right? Then we'll have if s1 the char at I equals s2 the char at j, then we're going to have dpij um, equals, so dpi -1 j -1 j -1 will not have will not be negative, right? So but I -1 may be negative. So we'll write if I greater than 0, right? We'll have this. Otherwise, we just still put this as default value. Um, so else, so we also put else if I greater than 0, then we're going to have dpi j equals dpi -1 j, right? Then what we need to do is that we need to go through these i's from 0 to n, and for the j equals n -1, right? That means we match to the last character of S2. So we're going to have start equals -1 and length equals integer dot max value. Then for int I equals 0, I smaller than n I plus plus. Then if we are going to have dp I m minus one done equal to minus one, and I minus dp I m minus one. This will be the rightmost index, right? Um, Plus one is smaller than length, then we're going to update our length equals I minus dp I m minus one plus one, and we're going to have start equals dp I m minus one, right? So in the end, we just need to return if length equals integer dot max value, then we use the empty string. There is no match. Otherwise, it will be s1 dot substring from start into start plus length. So doing like this, we'll see. Well, we are going to have a multiple by n space complexity, and also there are for loop um m multiple by n time complexity, right? Can we do better? Actually, we can. You'll see for every I, right? Every I, it's just coming from I minus one. So at least we can we can save the space complexity, right? So in order to save the space complexity, um, let's put these two for loops into a more general case. And this I and j, they can change the order, right? So we can write for this, we can add another for loop, right? For int j equals 0, j smaller than m, j plus plus. We can write something like so if this one equals, right? So let's just put if um j, we can have if this one equals, so we'll write if j equals 0, right? So that is I. Otherwise, so we are going to have we should have this, right? Have this one here. And this will be the same, right? So J. So this for loop, we just use don't write the same thing, right? And um, we also need to consider the M case. So because otherwise it's already, if we just have two multiple by M array, um, we need to mod, right? So this one we can mod 2 and mod 2, right? And this one will be mod 2. So we can write if we can compare here, right? So we can have start and the length somewhere here. And we write if j equals m minus 1 and dpi modded by 2 m minus 1 n equal to minus 1, right? And, and I minus dp I mod 2 m minus 1 plus 1 smaller than length, then we're going to update our length equals I minus dp I mod 2 m minus 1 plus 1, right? And also our length, our start will be dp I mod 2 m minus 1, right? So we don't need to have another for loop to compare. So in the end, we just return uh, if this length is max integer maximal, return empty string, right? Uh, we should put this one inside the for loop. So doing like this, we are using the rolling array to have our space complexity to be an OM, right? So that is M is very small number to 100, right? So that is a very small number for O for space. So the time complexity doesn't change, is still n multiplied by m, but space will be an OM space, right? So this will be the DP concept. And this question actually, besides this kind of DP way to do it, there is some other way to do. Let's talk about there is the way we did for the next array. So what is the next array, right? That is in um. So what is the next array? So we are going to have an 26 multiplied by n array called next array. That is from so this kind of next the second will be the character, right? So it's from this I index. What is the next index? Include this I for this character. So if we can pre-compose the next array of S1, right? Then what we do is that we have a just look at the S2 character by character, right? If we can go through um from S2, if it go through every character equals we can find the first go through character by character of S2. And if we can finish all of the next, right, from S2, we are going to um find one of the candidates, right? Um, so doing like this, we are going to have a multiple by 26 space complexity. But um, the things that this is better than a multiple by n, right? And of course, it's not good, better than our DP a moment ago that is OM. Um, but the time complexity is that because for every character from S1, right, we still need to go through these 20, these M characters. So, so it will also be an M multiplied by n time complexity. So let's use this concept to write our code. So we are going to have int n equals s1 dot length and m equals s2 dot length. So as we know, we are going to have an next array equals new int n multiplied by 26. Um, Initially, we can set all of the values for every row, right? For each row. Next, array is still -1. So we complete process this next array from the reverse order. For int I equals a minus 1, I is greater equal to 0, I minus minus. Then for int j equals 0, j is smaller than 26, j plus plus. We know next I j will be next I plus 1. It is well coming from the next position, next character. And only we need to update the current character. So next I S2 char at um char at I, right? Minus this A will be right. So this is from current for every we compose the next array is for every index. So what is the next index for this character, right? Then what we do is that we're going to have an int start equals -1 and the length equals integer dot max value. And for int I equals 0, I smaller than and I plus plus. For the first character, if that equal, we can continue, right? If s1 dot char at I doesn't equal to s2 dot char at 0, we just continue. Then we're going to have index equals -1, and for int j equals 0, j is smaller than m, j plus plus, right? So we're going to have index equals next um, index plus 1 uh, and s2 char at j um, -8, right? So let's see if this index equals -1, we didn't cannot find the next anymore, right? We just break. So after this for loop, um, if that means we go through J is already equals to M, right? So means we have match. So we'll say if this index doesn't equals to -1, that will be one of our candidate. So we're going to have if index minus I plus 1 smaller than length, then we're going to have length equals index minus I plus 1, right? And we're going to have start equals I. So if index equals -1 after we finish this M, right, we should break. Else just a break. So in the end, we just return length equals integer dot max value or not, right? So if it's the max value, we didn't have any match. Otherwise, we can have s1 dot substring start plus length, right? So this is a next array way. Um, we can have this one has m plus 1, right? Next, I equals n s2. So which one is out of bounds? So this is 26, apparently not this one. And 8 index 8 is auto bound of length 3. I equals n minus 1, I greater equal to 0, I minus minus for G, for every character be coming from the next one. Then next, I. Next, so which one have problem? Eight, what about? Uh, this is S1, right? There is nothing with related to S2, right? Because we are processing on the S1, pre-processing on the S1. Um, let's look. The first one, so this is not from -1, right? So actually we set this one as I -1, right? Because um, this we need a start index because this is for loop, right? So every time we need to have a I change to index change to the previous to this I, right? So doing like this, the next array we have an O m multiplied by n time complexity. But the space, right? Space will be an O(n) multiplied by 26 space. Uh, so this will be another way to do this question. It will be comparing to the DP we did a moment ago. It will be if we know this kind of necessary, this way will be kind of straightforward actually. Um, but the since that we still need a O uh O n time space complexity for this question. Can we do something? We have another way to do this question, right? So how can we do this question? Can we do better? Actually, this question, there is another way that is we do using two pointers. So what is the two pointers concept? So we have S1 and S2, right? So for every index in S1, right? If we try to match to to um, to match the strings in S2. So we can look at the character by character until if we have matched, for example, somewhere here, right, at this kind of index, it matches the J equals to M. That means we find a superset from from S1, right? And traditionally, what we do is that possibly if we want to find a superset, then we a moment ago this is at the start index. Then we have a move this index to start index plus one, right? But doing like this, even the time complexity, space complexity will be constant. But the worst case is that, for example, we match from this S to the end, right? It's an O(n) time complexity, and every index by index, it will be O(n) squared time complexity. Apparently, it will tell you for this kind of approach. But we can have different approaches. How do better is that if we find this index which matches J equals M, we can do reverse match from this index to match this as string, right? So how can we do reverse, right? For this is M minus one, this index, right? So they match, then M minus two, and trying to see if the index minus one, they equal not. If not, then uh, index minus two, right? So until we have this index go through to zero, right? So in this case, when we match, we'll find the window will be shrinked, right? So uh, so what does that mean? For example, we have A, B, C, A, B, C. For example, D, right? In our S2, for example, it is A, B, C, D, right? So if we find this A, and and we find a superset like this, right? And then we can reversely to have an index move back, shrink the left index to be here, right? So now our left index is at this one, right? Then this this will be the one which we have a candidate. The right edge is this D, and the shortest candidate, right? So we can compare with our global result. And next time for our we don't need to actually it's not necessary we compare the index here, right? We can go through this index from for example this index plus one, to check to repeat the process, right? So until we finish the matching. So apparently, this will be we don't have actual spaces, so it will be O1 space complexity. But what about the time complexity, right? Apparently, it will not be O n square, right? Because O n square is that if this is a very long array, we didn't match, right? We didn't find a match, we go through to the end. Then we can break, right? If we don't match for this string, we can break. And if also if we well say this first match, this is an um very long string, right? So there are two scenarios. One is that there is not too many repeated patterns from S1 to S2, right? Then we know, for example, didn't shrink too much. For example, we have left here. It still goes to here, right? That means if next round we have the index go to left +1, right? Apparently there is not too much repeating here, right? So we should go have the matching result somewhere uh, after the right index here, right? So we'll see this kind of matching will go to this index and go back and go through very long to the right, right? Even we shrink again, right? So here apparently there is not too many repeating arrays, right? So so we'll see if there is no repeating patterns, those kind of matching and shrinking, right? This will jump a lot from here to here. That means um, it will be a linear operation, right? If we can consider the extreme case if we don't match to S2, right? So that means we can break. And if, for example, we have matched only several windows, right? For example, three windows only. Um, Very long one, right? So that means there is no repeating one. So that means we come here, we didn't shrink too much, but the second round, apparently we should go long window after that. So there is not too much repeating work as well. Every number in S1 will be only visit the first time match and backwards match, right? So if there is repeating, we can shrink, right? So so this is the first case if there is no repeating patterns from S1 to S2. And the what actually for this kind of question problem is that there are a lot of repeating patterns. For example, S1 equals M, M, M until the end, right? S2 equals M, M. This will be the worst case when we match, right? Because every time we match this one, and we shrink to the beginning. And this one, and the next window, we match these three and then shrink to the beginning, right? And then so there are a lot of repeating patterns that will be the worst scenario. And then we'll see the worst scenario will have the time complexity O M multiplied by N, right? Just like this. That every character it will have an O M operations to match and back, right? But you will see if there is not any repeating patterns, apparently we can jump for the next round a lot, right? So we'll see the worst case will still be M multiplied by N. But if there are not too much too many repeating, it will go change to ON, right? So let's use write the code for this two pointer scenario, and int n equals s1 dot length and m equals s2 dot length. So what we do is that we also have int min plus integer dot or we can call length, right? Max value in the start equals -1. Then what we do is for int I equals 0, I smaller than n, I plus plus. And we can have an index which is the index in S2, right? So for int j equals I, j is smaller than n, j j is smaller than m, and index smaller than m, j is smaller than n, right? And index smaller than m, j plus plus. So let's say if S1 dot char at I plus S2 dot char at J, then we can have index move, right, from the second string. So we'll have if index equals M, then we find we can shrink the left one, right? And we can have int k equals J. And because we can write if we index down equal to m, right? If after we have uh this j loop, that means we didn't match, then we can break. So so in order we don't touch this change this index, we can use a new variable called int and in id equals m minus 1, and for k we'll say index greater equal to 0. We can also write k greater equal to I, right? But this is not necessary because we know from this I to index there is match. So that will always have a solution, right? So it will guarantee this k will greater equal to I. So if S1 dot char at k equals S2 dot char at ID, then we'll have ID minus minus, right? So after we coming from this index, um, this k have actual move, right? So we'll have k should increase by 1. So let's say if this j minus k plus 1 is smaller than me, then we'll have that's still called length, right? In our other smaller than length, then we're going to have our length equals j minus k plus 1, and start equals k, right? And we can have if we find this m, then we can have this I index move directly to k plus 1, right? And in the end, we can use this start index if it is -1, there is no match, right? Return start equals -1, then empty string. Otherwise, s1 dot substring start start plus length, right? Time arrow. This is in chart index. Some empty. This is empty. Let's look. Just two length start equals -1 for I index. This is a new is this one, right? We have a new variable. So if for index equals start integer max value I plus plus j equals I, j smaller than n, and index smaller than m if index plus plus. So if we have match, can have k equals j, and also we have id equals m minus 1 in S2, and this will be I k minus minus. You're right. This is k minus minus, and S1 child k equals S2, and we should remove this one. If j minus k plus 1 smaller than this length, then length equals start equals k, and then we move I equals k plus 1. So index equals m. For this one, we equals this will be j, right? We are from this not I, otherwise we will not change. So we'll see. This one is also an n multiplied n time complexity, but we have a constant space. So we have three solutions. The first one is the traditional DP, right? DP, which store the rightmost index of S1. And another use the next array, right? And then go through every character in S2. Um, and then the third one is we have a pointer, two pointers. And for every, if we find a candidate, then we reversely do a sequence to shrink, right? So we know the sequence end at this index. This will be a local smallest. Um, so we'll see. to prove this is also O M multiplied by N time complexity. So there are two kind of scenario, right? So if M this S1 and S2, there is not too many repeating patterns. That means we can jump a lot to next round, right? So if there is a lot of repeating patterns, right? So it will be like an OM multiplied by N. Uh, so this will be the third solutions. I'm going to write the Python code for the third solution only. Um, I can have an N M and length, mean length, mean length, and start equals length of S1, length of S2, mean length set float line F, and let's set this start as -1. We're going to have an I equals 0, I equals 0. Then wow, this kind of because um in Python, right, the for loop is different than the behavior of Java. So let's use while to be safe. Then we have index equals 0 and j equals I, right? Set a new variable. While j is smaller than n and the index is smaller than m, then if s1 dot j equals s2 dot index, then we can move index plus 1 plus equal to 1, right? So if we have index equals m, then we're going to have k equals j, and we're going to have an id equals m id. Let's say and new ID, right? So it because we want to use this ID to compare if it equals m or not, so we can have a new variable called IDD. Okay, IDD equals m minus 1. So while this IDD greater equal to 0, if s1 dot k equals s2 dot IDD, then we'll have IDD minus equal to 1, right? For this while loop, we should move this k minus equal to 1, right? And after this while loop, we need to move this k plus equal to 1, right? Adjust to the side index. So we'll write if j minus k plus 1 is smaller than the mean length, then we are going to have mean length update as j minus k plus 1. And we are going to have start equals k, right? And also, we should set our I equals k plus 1, right? Break. And for this while loop, um, we should have every time we move j by, this is like the for loop, right? For j, move one index. Mm. So Um, Also, if this index down equal to m, right? So we write if index down equal to m, just a break, right? We didn't match, final match. Just in the end, we just return this one. If we start equals -1, else it should be s1 to start plus min length.